All right, welcome back to Calculus. So today we're going to do Lesson 7, Integration by Substitution. And there are procedures for this and kind of rules and steps and examples, but honestly, I think the easiest way to learn them is just by seeing a bunch of examples in action. So that's what I'm going to do today. A little bit different from what we usually do, but that's it. So here we have the integral x squared plus 1 quantity squared times 2x dx. Now, if you wanted to integrate this, you could expand x squared plus 1 squared and then multiply everything by 2x. That's going to be incredibly time consuming. An alternative is using what's called u substitution. So when we use u substitution, you actually set a value equal to u, and then you take its derivative and try and eliminate something. So here in this example, we would say that u is equal to, I'm going to use x squared plus 1. And in that case, then du is going to be equal to 2x dx. So dx, right? So du over 2x is going to be equal to dx, okay? That's important information because then we can rewrite this integral. So now this is equal to u squared times, and actually, I didn't even need to do this here, but du is equal to 2x dx. Well, that's this. So u squared times du. So then I can take the integral here. I'm going to have 1/3 u cubed plus c. And all I have to do to finalize this is just substitute back in. So this is going to be equal to 1/3 times x squared plus 1 cubed plus c. Okay? That's it. You can see we saved a lot of steps there, and I actually did an extra step on accident. But pretty simple, pretty straightforward. So we'll do another example here. Okay, we have 4 times the cosine of 4x dx. Now in this situation, the hardest part of u substitution is kind of deciding what you want to use to substitute with, what you want to set u equal to. Now here, because I have a 4 cosine 4x dx, it's going to be easiest to get rid of that 4 if I have my u equal to 4x. So u is going to be equal to 4x, so du is going to be equal to 4 dx. So now I can rewrite this. I actually have the integral of cosine of 4x is just going to be cosine of u, and 4 dx is just du. So then my integral is equal to the sine of u plus c, which is equal to the sine of 4x plus c. Okay? Let's do one a little slightly more complicated. Here we have the integral of 8x times the square root of 4x squared plus 1 dx, and we want to set something equal to u. So maybe pause for a second and think about what you would set this equal to for u, what you would set u equal to. Okay, hopefully you're back now. I would set u equal to 4x squared plus 1, because if I do that, my derivative is going to be 8x. So I'm going to have du is equal to 8x dx, and then I can rewrite this. So I'm going to have the integral of, if I've got 8x, I'm just going to write, I'm actually going to just write u to the 1/2. That's easier for me, du, right? So I've got all of this. 1/2 is 3/2, okay? So I've got 2/3 u to the 3/2 plus c. So this is going to be equal to 2/3 times 4x squared plus 1 to the 3/2 plus c. All right? Let's do a few more examples here. 4 more. Oh, I got ink everywhere. Okay, we've got this integral of x times x squared plus 2 quantity cubed. So I'm going to set u equal to x squared plus 2, and then du is going to be equal to 2x dx. Well, you can see we have a tiny little bit of a problem here in that our du is not equal, like we have a 2x here instead of having a 2x here, so that's not that big of a problem actually. We can rewrite this. So we're going to have the integral of, well, du, if I want to, I could divide both sides by 2 here. So I have du over 2 is equal to x dx, right? So now that matches up. So this is going to be the integral of u cubed, and actually I need to rewrite this. I'm going to take this 1/2, well, I'll do it here in a minute, u cubed times du over 2. And that's equal to 1/2, I take that 1/2 outside, u cubed du. So now we're integrating. 1/2 times 1/4 is 1/8. U to the 4th plus c. So we've got 1/8 times x squared plus 2 to the 4th plus c. Okay? You don't have to expand that at all. All right, let's do some trig here. Nothing more fun than trig. We have an integral of the tangent from 0 to pi over 4 of tangent of x secant squared x dx. So for this problem, we're going to set u. If I set u equal to secant squared, I'm going to end up with more trigonometry than I really need. But if I set u equal to the tangent of x, then my derivative du is just going to be equal to secant squared x dx. And that's actually going to eliminate things there. So this is going to be equal to the integral from 0 to pi over 4 of u times, it's an ugly u times du, right? So this is going to be equal to 1/2 u squared. And this time I'm not going to say plus c because I'm actually evaluating this from 0 to pi over 4. Now, here is a trick of something you can do. I'm going to do this two ways. Follow me over here for a moment. I could rewrite this as 1/2 and substitute this in. So I have 1/2 times tangent squared of x, and then evaluate this from 0 to pi over 4. Okay, so this would be 1/2 times, that's the tangent of pi over 4. Tangent pi over 4 is just 1. So I have 1 minus tangent of 0 is 0. So I just have this equal to 1/2. But there's another way to do this. Rather than substituting the tangent back in for u, what we can do is actually change the parameters of our boundaries. So if I substitute in 0, so the tangent of 0 is equal to 0, the tangent of pi over 4 is equal to 1, I can actually evaluate this, instead of being from 0 to pi over 4, I can evaluate this from 0 to 1. And then I don't have to substitute back in at all, right? So this is just going to be equal to 1/2 times 1 minus 0, which equals 1/2. So in this particular problem, we didn't save that much time, but we did save a little bit of time, which is really helpful, especially when these get more complicated. All right, let's do another one. 0 to pi over 6 of sine 2 theta over cosine cubed 2 theta. Well, I would set my u equal to, I like these ones with division because it's kind of a fun, I don't know, challenge to see what we're going to do here. If I use cosine, I'm going to be able to have my derivative be negative sine. And I think that could be really helpful for us. So u is going to be cosine of 2 theta. So du is going to be equal to negative 2 sine of 2 theta d theta, okay? And hopefully you remembered there that not only are we taking the derivative of cosine, but we have to take the derivative of what's kind of inside there, right? Which in this case is 2. So this du over, we're trying to kind of get that 2 theta eliminated. Du over negative 2 is equal to sine 2 theta d theta, okay? And so that matches up there nicely. So this is going to be equal to, and in this case, I'm going to just pull that negative 1/2 out front, all right? And before I continue, I'm going to change my parameters here. So from 0 to pi over 6, well, the cosine of 0 is just 1, and the cosine of 2 pi over 6 is going to be cosine of pi over 3, which is, cosine of pi over 3, I think is 1/2. Yes. All right, 1/2. I'm getting smarter, students. So I'm going to change these parameters from 1 to 1/2 of, and I can write this. I'm going to have u to the negative 3rd power du, right? Hopefully you can see that. The du is the sine 2 theta d theta, and cosine negative 2 here. So this is going to be equal to negative 1/2 times, what am I doing here? Negative 1/2, if I add 1, I've got negative 2, so times negative 1/2, right? U to the negative 2, evaluated from 1 to 1/2. So I've got 1/4 times like, what do I have here? 1/2 to the negative, 1 second here. This is weird algebra. Okay, I've figured out what I was doing. So 1, it's going to be 1 over 1/2 squared, which is 1 over 1/4, which just becomes 4 minus 1, which equals 3/4. So you can do that on your calculator, you'll see. All right, and our last example here, the integral from 0 to 1 of x over 1 plus 5x squared. Well, hopefully by this time you've kind of figured out what you want your u to be. And so here I would say that u is going to be equal to 1 plus 5x squared. So du is going to be equal to 10x dx. And du over 10 is going to be equal to x dx. Hopefully you can see there that this is canceled out. Should I change my parameters? I think it's going to make life a little bit easier. So from 0 to 1, if I put in 0, I'm still just going to have 0, right? Or am I? 1? 0? 1? What am I doing? 0 to 1. Is that right? 0. No, that's 1. That's what I meant. Okay. And if I put in 1, I've got 6. Okay. So I have the integral from 1 to 6 of 1/10 times u to the negative 1 du. So this is equal to 1/10 times the natural log of u evaluated from 1 to 6. So this is equal to 1/10 times the natural log of 6 times the natural log of 1. Natural log of 1 is 0. So our final answer is the natural log of 6 over 10. All right. Hopefully all of that made sense. We'll do a lot of examples in class. I look forward to seeing you then. And if you have questions, leave them in the comments. Bye.